Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC U128D, refers to an issue where the automatic lighting control unit is unable to communicate with the gauge control module in the Honda Civic models from 2011 to 2015. This communication loss may stem from various electrical issues affecting the vehicle's operation and dashboard indicators. The gauge control module, which includes essential functions such as the tachometer and other gauges, is typically located behind the dashboard and depends on a stable power supply and ground connection to perform its duties. The automatic lighting control unit, responsible for controlling vehicle lighting, must maintain proper communication with this module for effective performance and safety. Users may notice issues such as malfunctioning dashboard indicators, difficulty in controlling automatic lights, or complete system failure, necessitating a detailed course of diagnostics to rectify the situation. DTC U128D indicates a communication failure between two crucial components: the automatic lighting control unit and the gauge control module located in the Honda Civic. The automatic lighting control unit plays a vital role in managing the vehicle's lighting system, ensuring that headlights and other lights function as needed, based on conditions like daylight or ambient light. The gauge control module is essential for monitoring and displaying critical vehicle information on the dashboard, including speed, fuel level, and engine RPM through the tachometer. For the system to function correctly, consistent communication is necessary. When this communication fails, it can lead to malfunctions in dashboard displays or lighting systems, which can cause safety issues during driving. Diagnosing this issue involves checking the connections and power supplies to both modules to identify the root cause of the communication failure. Several factors can lead to DTC U128D being triggered. Loose connections are a common problem, which may result from wear and tear or improper installation practices. When connections become loose, each module may not receive the necessary signals or power it requires, leading to communication failure. A faulty gauge control module, which could be due to wear or manufacturing defects, may also directly hinder communication. Another possible cause is a blown fuse, which may interrupt the electrical flow necessary for proper functionality. Finally, damaged or broken wiring can prevent the transmission of signals between these two key modules. Each potential failure point requires careful examination during the troubleshooting process to isolate the exact cause of the communication fault. When DTC U128D is present, several noticeable symptoms may arise that indicate an issue. One common symptom is malfunctioning dashboard indicators, where gauges may not respond correctly or display inaccurate readings. This could lead to confusion for the driver regarding critical metrics such as speed and fuel levels. Drivers may also experience issues with the automatic lighting system, where headlights may not turn on or off as expected, or they could operate erratically due to lack of communication with the gauge control module. Intermittent system behavior is another symptom, where the communication appears to function at times and fails at others, making diagnostics challenging. These symptoms warrant immediate attention to prevent further complications while driving, ensuring passenger safety and vehicle security. The first step in troubleshooting DTC U128D involves verifying the problem using the Honda Diagnostic System, HDS. Begin by clearing all diagnostic trouble codes recorded in the system. This resets the control modules, providing a clean slate for further tests. Next, turn the ignition switch to the lock position and then back to the on position. Maintaining this sequence is crucial, as it allows the vehicle systems to initialize correctly. After switching the ignition, wait for at least 6 seconds to ensure that all components have enough time to power up and establish communication. Following this, check for DTCs again using the HDS. If DTC U128D appears again, it confirms an ongoing issue, necessitating deeper investigation into the gauge control module or associated wiring. If it does not appear, it may indicate an intermittent failure, worth checking for any loose connections. In the second troubleshooting step, focus on determining the potential failure area related to DTC U128D. To do this, you select the BCAN control units information from the Body Electrical System Select menu on the HDS. This will enable you to access crucial information regarding the communication status of different control units linked through the Body Controller Area Network, BCAN. It is essential to check the Detect Not Available status for the Gauge Control Module. This will reveal whether communication exists between the automatic lighting control unit and the gauge control module. If it indicates detect, it means the components are communicating properly. However, absence may suggest a deeper issue, leading you to subsequent troubleshooting steps, focusing on wiring and connectors. The third step in addressing the DTC U128D involves checking the relevant fuses in the vehicle. Specifically, the focus is on fuse number A29, rated at 10 amps, located in the underhood fuse/relay box. This fuse is necessary for the power supply to the gauge control module and the automatic lighting control unit. Inspect the fuse visually for any signs of damage or breakage. If the fuse appears to be blown, it must be replaced promptly. However, if replacing the fuse results in it blowing again, this signals that there may be a short to ground in the circuit for that particular fuse, a fault that requires careful inspection to correct. Ignoring a blown fuse could lead to ongoing electrical issues and repeated communication failures in the affected modules. The fourth troubleshooting step involves checking the integrity of the +B backup line. Start by turning the ignition switch to the lock position to ensure complete system shutdown. Next, you need to disconnect the gauge control module by removing its 32P connector. This step is crucial since you will be measuring voltage with the connector removed, allowing for an accurate reading. Once disconnected, measure the voltage between test points as specified. Test point 1 is at the gauge control module's terminal number 1, designated by the white wire, WHT, while test point 2 is a body ground connection. If the measurement shows battery voltage, this indicates that the +B backup wire is functioning properly, allowing you to proceed to the next troubleshooting step. If not, an open or high resistance in the wire indicates further investigation and repair is necessary to restore communication. In the fifth troubleshooting step, the focus shifts to checking the IG1_meter line, which is also integral for the communication between modules. First, turn the ignition switch to the on IP position, which powers the modules without starting the engine. The next action involves measuring the voltage between designated test points. Test point 1 corresponds to terminal number 17 on the gauge control module's 32P connector, identified by the brown wire, BRN. Test point 2 remains a body ground connection. By measuring the voltage in this configuration, it can be determined if the IG1 meter wire is operational. A correct reading indicating battery voltage confirms that this wire is functioning properly, allowing you to move forward with the diagnosis. Conversely, if there is no voltage, it suggests an open or high resistance issue within the wiring, requiring further attention to resolve communication issues. Step 6 involves checking the ground connection lines, which are critical for the module operation. Turn the ignition switch to the lock position to ensure all systems have been powered down, as this allows for an accurate continuity test. Next, check for continuity between specific test points while the gauge control module remains disconnected. The first test point is at terminal number 4 on the 32P connector, represented by the black wire, black, while the second test point is a body ground. Testing for continuity in this manner will indicate whether the ground path is intact. If continuity is confirmed, this suggests that the ground line is functional. However, failure to establish continuity points to an open circuit or high resistance within the ground wiring, which needs to be repaired to restore proper communication and module functionality. For the 7th troubleshooting step, focus on verifying the beacon lines, which are critical for communication between the automatic lighting control unit and the gauge control module. Begin by disconnecting the automatic lighting control unit / sensor 7P connector before proceeding to check continuity. Continuity can be tested between specific terminals to confirm that signals are being transmitted correctly across the circuit. Test point 1 corresponds to terminal number 6 of the 7P connector, PNK, while test point 2 is set at terminal number 30 on the 32P connector of the gauge control module, PNK. If continuity is confirmed, the issue is likely an open or poor connection in the BCAN-L wire, and you may focus on correcting that path. However, if continuity does not exist, it indicates a possible issue in the BCAN-H wire, necessitating further inspection to determine and correct the communication fault. The 8th and final troubleshooting step once again assesses the BCAN lines to ensure thorough diagnostics. This time, both the gauge control module and the automatic lighting control unit / sensor connectors need to be disconnected. The sequence is important. Begin by ensuring that the ignition is set to lock 0 for safe handling. Once both connectors are detached, the continuity test is performed between the same terminals as in the previous steps. Checking test point 1 at the automatic lighting control unit's terminal number 6, PNK, and test point 2 at the gauge control module's terminal number 30, PNK, will either confirm or deny continuity. Should continuity be present, again, an open or poor connection is indicated in the BCAN-L wire. Conversely, a lack of continuity reinforces the suspicion of an issue with the BCAN-H wire, pinpointing where the communication breakdown may be happening and streamlining the repair process. After completing all the troubleshooting and necessary repairs for DTC U128D, it's crucial to perform final verification to ensure the issue has been successfully resolved. Begin by verifying all connections made during the troubleshooting process. Ensure that connectors are fastened tightly and that there are no signs of corrosion or wear present, as these can lead to future issues. Recheck the fuses that were involved, confirming they are in proper working order and are adequately supplying power to the relevant modules. Furthermore, inspect any wiring that may have been repaired to ensure that none have high resistance points or breaks. Finally, use the HDS to clear any diagnostic trouble codes that may still be stored in the system, providing a clean slate for subsequent monitoring. By accomplishing these steps, you can ensure that the vehicle is restored to proper working conditions. To prevent issues related to DTC U128D from occurring in the future, ongoing preventive maintenance is essential. Regularly inspecting connectors for signs of loose connections or corrosion can drastically reduce the chances of communication failures. Scheduled checks of fuses, particularly those critical to the gauge control module and the automatic lighting control unit, will help in identifying blown fuses before they lead to system failures. Furthermore, maintaining the integrity of wiring through routine inspections can ensure that there are no hidden damages or breaks that could impact the electrical communication between components. Incorporating these preventive measures into a consistent maintenance routine not only preserves the integrity of the vehicle's electrical systems, but also enhances overall vehicle reliability and safety. In conclusion, DTC U128D signifies a critical loss of communication between the automatic lighting control unit and the gauge control module in Honda Civic models from 2011 to 2015. This issue can impact essential vehicle systems, including dashboard functionalities and lighting controls, creating potential safety hazards for drivers. Successful troubleshooting involves a methodical approach, checking connections, power supplies, and relevant fuses to isolate and rectify the issue. The troubleshooting steps emphasize the importance of thorough diagnostics to pinpoint the exact cause of the failure, whether it be wiring faults, problematic modules, or blown fuses. Additionally, implementing preventive maintenance practices can significantly mitigate the occurrence of similar issues in the future. Engagement with a qualified technician or utilizing the HDS diagnostic tool is recommended for effective resolution and ensuring the vehicle operates as intended. Please like and subscribe to the channel. See you next time.